Hello, welcome to University. Today we're looking at the topic spatial matrices or types of spatial matrices. Normally, matrices don't have name. A matrix is a matrix. But there are some matrices that have special characteristics or features, hence they have special names. The first we have is the row matrix. The row matrix is a matrix with only one row. A matrix with only one row. Example of it is this. This is a row matrix. If you check, we have just one row here. Row 1 only. We can also have it as this. This is another row matrix. We can have it as this. We can have it as this. All of these are called row matrices because they have just one row. The second we have is a column matrix. The column matrix just has only one column. It has only one column. We also have this. So this is an example, or these are examples of column matrices. We have the third one, null or zero matrix. A zero matrix is a matrix which has all its elements as zero. Example is this. These are examples of zero matrices. All the elements are zero. All the elements are what? Zero. The fourth we have is what we call the square matrix. Now, the square matrix is simply a matrix. But if a matrix should form a square shape, it's called a square matrix. Do you get the point? So a 2 by 2, which is like this, for square matrix, a 2 by 2 matrix, which is 2, 4, 6, something like this. If you observe this, this is a square. We can also have a 3 by 3. This is 2 by 2, 3 by 3, and then I'll write it down in words. We can also have 4 by 4. We can have 5 by 5. All of these, etc., they are called square matrices. They form a square. The fifth matrix we have is what we call the diagonal matrix. Let me explain something for you before we continue. If we have a matrix like this, we have, let's say, 2, 6, 5, 4, 3, 8, 4, 7, 6. We have two diagonals here that is known under matrices and determinants. The first is this. This diagonal is called the leading diagonal or the main diagonal. Leading or the main diagonal. Then we also have this that goes from right to left. This is called the off diagonal. So I'm teaching you this because you need to know this to understand diagonal matrix. Now, for a diagonal matrix, it says that every other element is 0 except that of the leading diagonal. That means every other element here will be 0 except these elements here. So example, for if it was like a 2 by 2, here will be 3, 4, 0, 0. Observe, this is the leading diagonal. It will have values, but the off diagonal has no value. Other elements have no value. We also have here 5, 0, 0, 0, 2, 0, 6, no, 0, 0, 6. Observe here again, the leading diagonals alone have value, while the non-leading diagonals, or those are not the leading diagonals, are all 0. So this is the fifth kind of spatial matrix. The sixth is what we call the unit or identity matrix. Now, the unit or identity matrix is the same as is a type of diagonal matrix, but it is one in which the value of the leading diagonal is unity, which is 1. Example are these. We have 1, 0, 0, 1. Observe here, the leading diagonal is all ones, that's all unity. You can also have it in 3 by 3 form, where we have 1, 1, 1, 0, 0, 0, 0, 0, 0. This is also a unit or identity matrix. We also have it like this: 1, 0, 0. Okay, for a 4 by 4, then we have 1, 1, and 1. That's for a 4 by 4. So these are 6 types of spatial matrices. Now, for the seventh type of spatial matrix we have, it's called the equal matrices. Two matrices can be said to be equal on one condition. That's if they are of the same order. A 2 by 2 matrix can be equal to another 2 by 2 matrix. A 3 by 3 can be equal to another 3 by 3. But a 2 by 2 cannot be equal to a 3 by 3. Do you get? Now, let me give an example for better understanding. They said if A is equal to B, where A is, this is the match for A, 2, 4, 1, 6, and B equal to A, B, C, D. They said find A, B, C, and D. Find the elements in B, A, B, C, and D. Now it's very simple. We know that this is a 2 by 2, this is a 2 by 2. So if we are equating them, we're equating them by their positions, that's the element position. Element A here will be equal to 2 here. B will be equal to 4, C will be equal to 1, and D will be equal to 6. So this is what we mean when we say equal matrices. So let me give a breakdown of everything we just said. For the types of special matrices, we first is the row matrix, the column matrix, the null or zero matrix, the square matrix, the diagonal matrix, the unit or identity matrix, and the seventh we have the equal matrices. So these are some of the special matrices we have. Please do to like, subscribe to the channel and share this video. If you have any special matrix you know about that was not mentioned, please drop it in the comment section. See you in our next clip.